Trigonometry, Chapter 7, Applications of Trigonometry, Vectors, Section 1, Oblique Triangles and the Law of Sines, Video 4, The Law of Sines, Example 1. This series is based on content from Pearson's Trigonometry, 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we derived the law of sines in any triangle ABC. Sine of angle A divided by side A equals sine of angle B divided by side B, which also equals sine of angle C divided by side C. It should be pointed out that we only use two of these three ratios at a time. In this video, we demonstrate an example of the law of sines. Surprise, surprise. For example, an engineer wishes to measure the distance across a river indicated by segment BC. He determines that angle C is 112.90 degrees, angle A is 31.10 degrees, and B, the distance between A and C, is 347.6 feet. Find the distance across the river, in this picture represented by side A, which makes sense because it's opposite angle A. My understanding is that this is a fairly common scenario in surveying, where you put a total station at point C and a total station at point A. You know the distance between the two, and then both of them focus on point B and measure the corresponding angles. Notice that we do have angle, side, angle, which means that we will have a unique triangle. Now, we will use the law of sines, but there's an initial problem that needs to be overcome, and this happens rather frequently with the law of sines. We currently know angle A, angle C, and side B, and we wish to find side A. And if you notice in our three ratios, I've highlighted in yellow the things we know and in green the thing we want to know. So what's the problem? Well, when using the law of sines, we choose two of the three ratios. We must include the ratio that contains the value we are seeking, in this case, side A. So we must use sine of A over A. However, regardless of which other ratio we choose to form an equation, there will be too many unknowns. For example, suppose we choose the second ratio as well. Well, we want to find the value of side A in green, and we know the values of angle A and side B in yellow, but we do not know the value of angle B, which is necessary to use these two ratios in a proportion as a means to find A. In other words, algebraically speaking, if you want to know the value of one variable, you better know the values of all the others, and we don't know the value of angle B. And we run into the same problem if we choose the third ratio, sine of C over C, because we know angle C but not side C. So if we use these two ratios, we have an unknown value in the way, side C. Now, when using the law of sines to find part of a triangle, you must have a complete angle side pair. For example, side B and angle B would be a complete angle side pair, as would side C and angle C, or side C and angle and side A and angle A. Now, of course, one of them has an unknown, that's what you're looking for, but the other ratio, you must know both the angle and the side. We do not have any complete angle side pairs yet. We're missing both angle A and side A. We're missing angles B. We're missing side C. So how can we overcome this? Well, let's remind ourselves of what we have, the things in yellow. Now, in order to complete an angle side pair, we need either side A, which we're looking for, angle B, or side C, which is the easiest to find. Well, it should be obvious it's the angle because we know two of the three angles. Since we know the values of angle A and C, finding the value of angle B is straightforward. B is simply 180 minus the other two angles, which is 36.0 degrees. So we're going to add angle B to our list of things that we know. And now we know the complete angle side pair for the second ratio, sine of B over B. Using this ratio along with the first one, use this ratio along with the first one since we're solving for side A. All right, so in other words, make sure when you set up the law of sines, you know three of the four values. In this case, we found angle B by subtracting 180 minus the two given angles. And now we just do a little bit of algebra. There's the setup. We can cross multiply. That'll give us 347.6 times sine of 31.10 degrees equals A times 36.00 degrees. Again, if cross multiplying is one of those things that make you go, wait a minute, what's going on? Cross multiplying actually is one of those things that people tend to just know, or rather want to do, and sometimes it's the wrong time to do it. The only time to cross multiply is when you have one fraction equal to one fraction, and then you want to get rid of the fractions. So cross multiply and you get this. At this point, it's a pretty straight shot to solve for A. We'll just divide both sides by sine of 36 degrees, and we get A is 347.6 times sine of 31.10 degrees divided by sine of 36.00 degrees. And we get out a calculator, and we get that A is approximately 305.5 feet. It's problems like this that make me say trigonometry is good for measuring things when you can't just drag a tape measure across it. For example, it'd be hard to just drag a tape measure across this river. Now, notice the answer was kept as precisely as possible until the very end. In other words, I never put anything into a calculator until I absolutely had to right here. And that was on purpose because intermediate calculations between the beginning and the end of an equation can introduce an error into your results, an error which can compound upon further calculations. So a good rule of thumb is don't get out the calculator until you absolutely have to. Now, if you used it for the subtraction problem, that's okay. No accuracy was lost here. No rounding was done. But I would not use the calculator to evaluate A until the very end. Now you try. Pause the video and answer the following. Find the distance AB across the river if BC is 354 meters, angle B is 112 degrees 10 minutes, and angle C is 15 degrees 20 minutes. Pause the video, give it a try. All right, here's your warning if you have not paused the video yet. Solution in 3, 2, and 1. As before, we need to find angle A because that would give us the complete angle side pair. Angle A is 180 minus B and C, 52 degrees 30 minutes. Then we can set up sine of 52 degrees 30 minutes, side angle A, divided by side A, 354 meters, equals sine of 15 degrees 20 minutes, angle C, over side C, which I've represented as segment AB. Solve, and we get AB is approximately 118 meters.